Hi, welcome back. Today I'm going to try to explain today's LeetCode daily question, which is this question right here. So you're given an array and an integer, and you're going to do this operation right here. So if you do these three steps, it is considered as one operation. First, you're going to take the two smallest integers from the array, and then remove it and add this equation back to the array and put it anywhere at any index. And we need to return the minimum number of times we do all of this operation so that all of the elements are greater than or equal to k. In order to clarify this further, let's use a test case. For example, if we have this example right here, we see that there's three elements where their value is less than k, which is the 2 here and the 1 and 3 here. So we're going to get the two smallest, which is 1 and 2. We remove it from the array, let's say in this case, and we are going to put this equation, which is the minimum out of the two, 1, multiplied by 2 plus 2, which is equals to 4. So this one is one operation. Next, we are going to put the 4 here, and we see that there's two elements where they are smaller than k, which is 3 and 4, and we are going to repeat the process for the two of them. So 3 and 4, and 3 times 2 plus 4 is equals to 10. And we remove this and add back. We can see that each element in the array is at least k or larger than k. So in total, this requires two operations. And let's just get started on the coding part. First of all, we see from the question, it mentions that we can only apply the operation right here when the array itself contains at least two elements. So that is our constraint, and we're going to put it at top. So if nums.length is smaller than 2, then we're going to return -1 since it is not possible. Then we're going to choose a data structure, and one of the data structure that fits this question is the priority queue, because the priority queue already sort the elements by itself, and if you use the method of queue.pick or queue.poll, it will try to get the smallest elements out of the array. So we are going to initialize the priority queue here. New priority queue. And here we are using a long instead of an integer, because although all of the elements in the array is an integer, but once we operate this equation right here, it might get larger than the range of an integer. So it is better if we store it in the long. And now we are going to iterate every element in the array and try to just put it in the queue. So for int I equals 0, I smaller than nums.length, I plus q at here, since the type of the element in the array is an integer, we need to convert it to long first before putting it in the queue, which uses the method long.valueOf. So long.valueOf nums I. Our next step would be trying to find the smallest element in the queue and see if it's larger or equal to k. Because if it's larger or equal to k, that means we already ensure that all of the elements also satisfy that requirement. And in order to do that, we can just use the method q.pick, because we are already using a priority queue here that sorted that has the smallest number as the most, like with the highest priority. So we can just use the pick method and check that. So if q.pick is larger or equal to k, that means we don't have to do any operations, and we can just return 0 operations. And else we need to count the number of operations. So we need a variable to store the number of operations, which is operations equals to 0. And then we need to continue doing the operations up until qpick is larger or equal to k. So we can write the condition as while q.pick is smaller than k. And since we cannot do this operation when the size of the queue is smaller than 2, we just need to put a restriction right here. So if q.size is smaller than 2, we are just going to return the number of operations. And luckily for us, this question says that the input is generated such that an answer always exists. So we don't have to take care of the case of, let's say arbitrarily we have an array of like 1, 1, 1, and the case equals to like 1000. Since this is like not achievable, so we are already granted that if we do these operations right here, then we are always going to get there's going to be at least, there's going to be an answer no matter what. Okay, so let's continue on from here, and we are trying to do these operations right here. So we can do this together in the priority queue by using the poll method. So first we need to get the smallest, which is q.poll, and we also need to get the second smallest, which is also equals to q.poll. The reason why we can do this is, for example, if our queue sorted 1, 2, 3, 4, 5, this line right here is saying get the smallest and remove it from the queue, and this is the result after the first line. And when we go here, we see that it retrieves the second smallest value and remove that. Okay, so now we are going to do the third step of this operation, which is adding this to the array, which in this case is our queue. So q add smallest times 2 plus second smallest. And we are just going to append the number of operations by 1. And at last we just need to return the number of operations. Return operations. And we'll try to see if we miss anything. Let me check. Oh, we should have used a long here, because our priority queue type is a long. So long and long. And we'll try to submit and see. Yeah, so this is the solution for today's question. It wasn't really hard, and it's also a medium level question. It's more like knowing which data structure you need to use, and it's pretty straightforward because you can just directly do this operation in the atlas, like after you do all of this initialization, but it's pretty good. So I guess that's it for today, and I'll see you guys again next time.